So today at ATS, we're up in the race shop. We're talking about our new turbo benchtop controller. This is Steed. Brought him in. He's running around the turbo shop, helping us make all these really cool, innovative, fun features that we can help the industry out with. So we're going to talk about the benchtop tester and how it is going to make everybody's life easier, especially if you're a turbo rebuilder. One of the real needs in the turbo world today is being able to test these actuators. So, you know, over the years, all the turbo manufacturers, Holset, Garrett, pretty much everything across the board, Hino, all over the world, everybody not only is going to VGT turbos, which is a variable turbo, but they're also controlling them electronically. And the electronics is what's really creating some problems for everybody in the turbo world, because we've got to be able to test these things, not only rebuilding the turbos, but rebuilding the actuators, and then the actuators themselves, checking them and making sure they actuate right. You know, you might do a great job with your turbo, but getting the actual actuator to actuate the turbo properly has been a real science. So now, you know, pretty much the secret's out. We have a nice benchtop tester here that you see that is relatively straightforward. Kind of walk you through it. You have your basic cord that plugs into the turbo. We have different cables, adapter cables that plug into it. So each one of these adapter cables for literally every turbo out there. When I say every turbo out there, if it's a turbo that we don't have currently, send us your actuator in and we'll do the mapping for you for free of charge. Add it to the software, update the box, and presto, we have a system to control and test your actuators. So some of these actuators also have to be calibrated. What you see here is the Cummins. And the Cummins actuator not only actuates the vanes open to close, but it has to be calibrated. That means when you rebuild the turbo, then add the actuator to it, you have to calibrate this actuator so it essentially knows fully open to fully closed. And if you don't do that, then you put it on the truck, the turbo doesn't work, or you have to calibrate it on the truck on top of that, which creates a whole nother mess. And especially when you're a turbo rebuilder, or say you're a salvage yard that's pulling these off and you want to make sure they work, then it's really nice to give your customer something that's calibrated, that works, that is just going to go out the door. So we're going to kind of walk through how the calibration works. So we'll kind of do a step-by-step, and once we walk through it with the whole set, you'll have a really good idea of how to actuate it or how to calibrate any of them. Now, one of the things that we made the software really super simple. I mean, once you plug in your benchtop tester, it just hooks into a USB. Add the software, just go to atsdiesel.com and you can download the software. We'll also send it with the benchtop tester. But once you plug it in, it's literally going to tell you, you know, if you're unplugged from the USB, if the controller, if the computer is not seeing the benchtop tester, it's going to tell you. So we've just turned it off. Now that it's off, you know, it's obviously saying there's no turbo selected because it can't even see the benchtop tester. So we'll power it on and let it boot up. And then once it boots up, the computer sees it. Now this is basically telling us that it's real easy. And it's really designed this way so, you know, any of your guys in the shop, you know, whether it's shop floor or in the turbo shop or whoever it is, you know, you're in an assembly line and you're running through these turbos, make it pretty easy to turn the computer on, turn on the benchtop tester. If it's unplugged, it tells you. It goes to the point, if it doesn't see the controller, it tells you. In this case, you'll basically see the screen. So kind of when we get into it, you have VGT control and you have VGT calibration. If the VGT calibration is not turned on, that means, or if it's grayed out, that means there's no calibration to be had. So it basically, the controller sweeps from 0 to 100. That's basically what you get. If there is a VGT calibration available, then it's going to have the ability it's going to need to be calibrated. Well, in this case, first thing we have to do is we have to select our turbo. So you have a turbo selection here, and you get a pretty good idea of how many different turbos are programmed into this box. You know, everything from the Duramax L5P to all the Hella, International, John Deere, Navistar, of course, all the Cummins, you know, whether it's the Detroit, the big Cummins, the small Cummins like you have here, that we're just going to go directly to these guys. We have the AT351 and the 300 VGT. Now, once you plug it in, a couple of really cool things you're going to find here. You know, obviously, we're plugged into the turbo, or into the turbo, because you're seeing that it's plugged in, but it's also identifying the controller that's on here. Really neat feature of this software that you don't get, you know, with pretty much anything else out there, is we'll show you what your part number is, your serial number, your firmware. The really neat thing is for you turbo rebuilders out there, when you're using used actuators or whatever it might be, you can actually see how many cycles, ignition cycles, this particular one has been cycled 355 times. There's 6 hours and 32 minutes on it. It also shows you what your max temperature is. So with any electronics, anytime you're running, you know, like anything 200 degrees or so is like the max temperature that you can really run on these actuators. Otherwise they just break down, that you get solder joint problems and they just start to fail. So, you know, if you have something that's had a max temperature, you know, of probably 160 or so, you know, 180.
About 90 degrees Celsius, so right around 180 to 200 degrees is about the max you want to get. Once you get around 90 degrees, that's when solder starts reflowing. The devices, the ICs can start coming off, the motors will burn up. So as long as you're below 180 to 200 degrees, you should be fine.
So this is, you know, really, really good information to pay attention to, like I say, especially on these late model electric actuators like the Cummins. It can save you a lot of time. Now, we'll go ahead and go through the calibration. And
I was going to say, another good point is there's actually a lot of counterfeiters out there that are actually rebuilding these actuators. So you may have a supplier, or you may buy them on eBay and they say it's a rebuilt actuator and you might be getting a good deal on them. Well, what's really interesting is when you do connect it, you can actually verify that. And if you're getting the same actuator from the same vendor over and over and over again, you might want to take note of the serial number. And if you see the same actuator with the same serial number over and over and over again, you know that they're pirating code. And they're probably lying to you about how well they're rebuilt.
Yeah, we've actually had some calls on that. We've heard of that, where they come in and it's the exact same number over and over and over.
So like on this particular actuator, you could see that even though it has 6 hours on it, our turbo tech, he's been using this for testing, but you can see that it hasn't been over room temperature. It's been 82 degrees through its whole life. It's max temperature it's in.
So I suppose this will be a good one to start with.
Yeah.
Cool.
Be interesting to see what that other one does.
We've actually got a bad actuator that we'll put on here, that we'll plug in real quick and kind of show you what happens. Now, one of the things that to note is you won't really be able to hear it here on the audio, but this actuator is relatively noisy, and it's kind of a good. Well, actually, maybe you can hear that. I'm going to hold it up close to my microphone.
Probably go this side where it says whole set. That's where the motor's at, and that's where the bearings are at.
So you kind of hear that. That basically is a sign of an actuator that's beginning to fail. So even though it's sweeping 0 to 100%, which we're going to show you that as we calibrate it, even though it's completely sweeping, that one's vibrating, buzzing, kind of making some noise. You hear the bearings going out. So probably stay away from that. But you'll really get comfortable with how to use this software and how to test the turbo. You know, what's a perfectly good actuator, what's a failing actuator, one that's sticking. The software actually shows you that as well, as when it starts to sweep from 0 to 100%. So we'll dig into this real quick and we'll do the calibration.
I was going to say, you can point out to you right here that this actuator is obviously older. Max temperature has been 168 degrees Fahrenheit, and it has 2,600 hours. Still, use-wise, It still hasn't really been used too much. It's probably about a quarter or so through its lifespan.
It's got a couple hours on it. That's really helpful information to have.
Oh yeah.
That's really nice. So we'll jump into calibration here. Now, like I say, remember that when you're doing the calibration, if you do not get the VGT calibration, if that's grayed out, then it's not calibratable. So it just basically sweeps to 0 to 100%. So we get a VGT calibration. Simply go to calibrate. Now this is very important. Read the instructions here. It's step by step, and especially when you're having your guys in the shop, you know, that are running this that maybe they don't have a ton of experience, just read the step by step instruction and take it step by step, and then it's going to walk you through it. It either passes or it fails. Pretty straightforward. So basically, the first thing it's telling us to do is take the actuator off, and this is kind of how you do it in the vehicle as well, for those of you that have calibrated these in the vehicle. Unfortunately, on a 6.7 Cummins, you have to drain the coolant, out of the engine, which kind of sucks. But anyway, it's something you have to do. So we've taken the actuator off, and you can kind of see your gear here. So as you take a look at that, and then we're going to proceed. Then we have another warning screen. So basically we're erasing it. And what it's doing now is it's basically looking for its center. So now that that's done, all it does is it spins around, it looks for its center, so it does the first part of the calibration. And then we're going to bolt it back on. So now that we've got the first part of it, and then we're ready to put the actuator on, one of the things to note, these are your vanes that are, going in and out, of course. So you want to always run the vanes in the max open position, and that puts your cam, this guy, all the way towards the exhaust side. So that's closed, and that's basically completely open. So that's where we're going to start. And then you're going to just basically line up the
That's better.
Looking good.
Now the biggest thing is too, when you're calibrating these, if you just try to hold it by your hand, or you just put the bolts in lightly, if it shifts too much, it's going to fail. And if we're using just for testing, you have it light, that's probably fine. But if you're not torquing it down for the actual calibration to send to a customer, then you're kind of expecting a problem.
Yeah, just kind of take your time and get it all nice and lined up and tight. This is a very important part of sending a turbo out to your customer, though. So now that it's lined up, just follow the instructions. We're going to hit OK. And basically what it did, it went to the 0 point, and then it's going to go back all the way to 100, and then calibrate.
So right now the calibration is done and it started to sweep, and that's because in the VGT control we still had it on oscillating, so it defaulted to go back to its sweeping command. But that's it. That's all you have to do is you align the gear through the steps, just follow the instructions, rebolt the turbo, the actuator to the turbo, and if it all works, you're fine. Now we can do a demonstration with that actuator without the center cartridge, and you can see that it'll actually go over its range, and it'll actually tell you that there's an error.
So in the software itself, it basically shows you can go like 0%, 100%. Now the important thing to look at here is as you're increasing the commanded, you want to make sure that your commanded and your actual is the same. So when you go up to 100%, as long as what we're commanding the actuator follows the actual, then you've got a controller that's good and you have a turbo that's not sticky. And the other option that's in here is you can isolate. And if you go to isolate, then it basically just commands open, close, and sometimes we'll run these on the bench for hours, just to a customer says they're having a problem with the controller or the turbo, whatever, you can bring a turbo in and all assembled, hook it up and just run it in, out, and it just basically isolates it just like it would in the truck. So that gives you an idea. This is a really nice, healthy turbo. It's not sticky. It's not binding up. When you get a really old turbo, you find them kind of binding up, and you can really diagnose, what's going on with it. So we're going to stop the isolation here, and then that's pretty much the entire calibration of this turbo. We checked it out. This thing's ready to be shipped off to a customer once we finish assembling. So you want to show them what the other actuator does? See what we can do.
All right, so right now all we're going to do is just plug this in. So went to actuator error, which is kind of interesting. So when you get an actuator error, the first thing you kind of want to do is just try to reset it. So resetting it, when you press the button, all that's doing is just killing the power. It's not really doing anything else but then literally just turning the actuator, whatever device you have connected, off. And you can tell it's now de-energized because now it says not detected. Powered up. So really interesting, like I just mentioned to Clint, that the older generation, I would say 2007, 2008 series, definitely early on, for some reason the actuator sometimes would actually fail into an operating state. And even though the actuator is not calibrated to any turbo, and it actually should be in a non-calibrated state or an errored state, it's actually allowing us to control it. So if you click oscillate, it'll actually sweep back and forth like it's supposed to. But in reality, it's not calibrated to any one particular turbo because the actuator itself no longer knows the actual range.
See the gear?
If you have an older actuator or an older turbo from like 2007, 2008, and your actuator's like this, you're probably fine if you bolt it up to the original center cartridge that hasn't been rebuilt. But once you rebuild and you start moving with the geometry of everything on the inside of the turbo, you pretty much lost that. No matter what, it needs to be calibrated. So let's go ahead and click oscillate to get that to stop. Click on menu, and let's go ahead and do Vgt Calibration. So the whole point we're trying to do now, click calibrate, is we're actually going to do a calibration without the center cartridge. And we're going to basically show you that if there's something going on during the calibration process, it will error out.
All right, so we're going to just run through it. Now we're not going to bolt it to the turbo in this case. We're just going to go through the calibration without it. And it's going to, basically what it's doing now, it's trying to find its 0 to 100 set point, but it's not going to find it because it doesn't have vanes that's stopping it.
So you'll see on the internet, there's companies out there that saying whole set actuators that don't need to be calibrated. I got two assumptions because I'm not 100% sure. One is they calibrate it on a center cartridge. They set it to a known position, you know, all the way closed, all the way open, whatever the two, and they tell you to do the same thing with the hope when you bolt it up it's actually calibrated. The problem with that philosophy is you're literally looking at a range, and that range can be from 0 to 1,000 that the turbo can actually go to. Now the turbo physically won't go from 0 to 1,000. It'll go from, let's say, 5 to 950, or 5 or 10 to 900. And what the actuator does in the calibration process is it rotates all the way one direction. I don't know if you can really tell, but this is what it looks like on the inside. And there's this little magnet right here. Now the magnet goes over particular sensors, and it knows where it's at in its track. Once it knows that this is, let's say, all the way closed or all the way open, and it rotates this direction here, and it does the same thing, it takes that span and divide it to figure out exactly where it's at. And if you don't do that process, then it's automatically assuming whatever turbo it came off of, that's the current span. And if you have a built turbo, doesn't matter who it came from, they completely ripped it apart and put it back together. It's not in the same spot. So if you got one of these pre-calibrated actuators and put it on your turbo, your exhaust brake may not be as tight as it should be. It may be too tight, or it may not open up all the way, and you'll actually overspool your turbo. So that's just something to keep in mind, because the turbo won't know where really to go. So don't believe too much of the gimmicks where you don't need to calibrate these things.
Yeah. So in another sense, a lot of these aftermarket actuators, you know, you really do have to be careful. You know, a lot of times they will work, like Steed says, but often, you know, the complaints are the exhaust brake doesn't work nearly as well as it did, or it doesn't open up all the way. So again, because it just doesn't know exactly where it's at. So really a quality whole set controller, you know, is really the way to go. Now, one other thing I want to add on the Cummins side of things is just because you calibrate your turbo on every single application doesn't always mean that it's going to go on the truck and it's going to work perfectly. There are sets, defaults that happen on the Cummins computer, on the Chrysler computer, that if you have a really failed turbo and it basically won't open completely or won't close completely, the computer will set some defaults. And generally, like new turbos we'll send out, generally probably 90–95% of them go on and everything's fine. You don't have to do a recalibrate on the vehicle, but about 5% or so, you do have to do a recalibrate in order to get a full exhaust brake. And that's just something we've recently noticed that on a lot of these trucks, and it seems to be trucks that have a really failed turbo. Like, I mean, it's just completely warped, and it's limited that thing so much. So just because you calibrate the turbo doesn't 100% always mean it's going to go in the vehicle and it's going to always work. So just note that when you send these turbos out after the rebuilt. But for the most part, you know, this calibration tool 100% calibrates the actuator. You're good to go. It's just the truck side. In some cases, you have to be aware, you know, there's other things that can go wrong there.
So the cool thing is, if you have an actuator in and for some reason you want to get the exact same part number, like we mentioned earlier, you can actually read the part number. Sorry. Took Clint's away, we didn't take mine. Which is really cool. If you back up real quick, we can kind of demonstrate it. You probably won't be able to see. So like this actuator here, there's no part number, the sticker's gone. This is actually really good for turbo rebuilders. So if you're rebuilding turbos, and I'm just that shady guy that bought a turbo from you, and I airbrushed this and made it all look brand new again and say, hey, you sold me a bad actuator, something to put on the bill, the receipt, is maybe put the serial number and the part number of the devices. So you can actually use, if you want to serialize your turbos, use the actuator as your serial number, and if it comes back, you can verify that, hey, this is a different actuator than I actually sent out the door. So there's definitely a lot of opportunity here.
So in this case, this is like a brand new whole set. You'll notice the number matches.
So the number right here, are you on 3? So you're on 300. So okay, so there's a difference between the 351 and 300. The control calibration, that's generally the same. There's slight differences, but not too much you guys really got to worry about. But on the serial number itself, that's really what makes a difference. So on the 300, the serial number is written in hexadecimal, where the 351, they were at them in decimal, so just regular numbers. All right. So another aspect for turbo rebuilders, if you have your own data plate that you bolt onto the turbo, that's great. But if you don't, if you're a small time guy, or if you're a salvage yard, you can actually use the serial number of the actuator. So if I'm a shady person, I bought one of your reman turbos or one of your used turbos, and then I say the actuator don't work, and I send it back intentionally with a bad actuator. If you captured that data before you shipped it out to me, you'll actually see, so on the bill of sale, me personally, I would probably have this actuator serial number as my turbo serial number. So if I swap the actuators out, you now know that I did something shady and it's not right. And if it's on a bill of sale, then you're protected. So on here, we can see that the part number is 2837675, and then the serial number, you're going to see a couple of characters, but it's just the numbers, 26807.
You got a match.
So that's the serial number that's on here. When you click on 300, the only real difference between the turbos for the most part is actually how we read the serial number. So now we're on a 300 VG, even though it's 351, it takes that same decimal serial number and converts it to hexadecimal. So when you look at the 300 actuator, I wish we actually grabbed one from downstairs, but you would actually see, you wouldn't have that long serial number. You're just going to have that hexadecimal number, and then that hexadecimal number that's actually either stamped or on the sticker will match what's on the screen. So that's a really cool feature.
But definitely a nice part about this software is if you do have a warranty concern, plug it in, it gives it to you, it pulls you right out of it, so it doesn't matter what they do to the actuator, you're going to see it.
Yeah,
right?
Especially if you have someone that's lazy and they don't reroute the lines, or if they have a custom configuration, basically swapping these onto another motor, and they didn't cool them, you'll see that that temperature is going to be a lot hotter. So on average, from what I've seen from my experience, you're looking at 120 to 130 degrees on average. Granted, if you're towing, you're going to have that higher temperature, which is why the higher temperature on these can go up. But if you don't have any cooling going to that turbo whatsoever, you're definitely going to be around that 90 degrees Celsius range, and that thing's probably cooked. So another warranty consideration for you guys, I think. So it definitely has a lot of use other than just a calibration feature.
So some of the flexibility of the benchtop tester is currently you have it set up to pretty much do about 20 different turbos. Like say every single one of them has a different harness that you will plug in to basically jumper between it, so we have all our different harnesses. But along with that is that it will also control 24 volt systems, and one of the issues, of course, with electronics generally, you have a 12 volt actuator versus a 24 volt actuator, is flipping that back and forth. That doesn't really mess you up too much. If you go from 12 volt to 24 volt, generally all that happens is it just doesn't detect, as you're seeing, doesn't detect the actuator. So pretty much you don't really have to worry about whether it's a 12 volt or 24 volt, the software will tell you. And it also has the ability to do a lot of other testing, which we'll get into here in 1 second. Steed just grabbed a L5P turbo off of 2020 Duramax.
Yeah, so there's currently 13 different adapters, but each adapter can control quite a few different turbos. So it just depends on the application. So if you look on the software, you're going to see a turbo adapter. In this case, it's on a 300 VG, and it tells you to use BT 101. So another note is when you actually select the turbos, there's actually going to be a pop-up, and because each of these are controlled with a different protocol, that you want to select a turbo, make sure you follow the steps in the menu, And then when you click OK, then connect the turbo. If you don't do that, you can pretty much crash the network.
Which won't hurt anything, it just doesn't boot up.
Yeah, you just reset it.
So in the software stuff, like Steed says, BT101, all of the harnesses are labeled what they are exactly now. Just because they say ISB, ISC, ISL, blah, 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 pack card, doesn't mean that's the only turbos it's just the only turbos that we put on the label. So really pay attention to the actual adapter harness. As soon as you select that turbo, go to the turbo, it's going to tell you, in this case, we're going to go to the L5P. There's a lot of them in here. Where's it at? There it is.
Right there.
Go to the L5P.
Now this is the menu I was talking about. We kind of skipped through it before, but all this is basically telling you is to make sure before you click OK, because right now it's still on the whole set protocol, disconnect it from the turbo, and then read it, click OK, and that just basically resets it from the whole set protocol to the L5P protocol. And if you click it beforehand, sometimes you're fine, but most of the time what happens, it just stops communicating. You just got to turn the benchtop tester off, get everything to reset, power it back up.
So we got our BT108, plug that in, and as you see, you go to menu. Guess what? The Vgt calibration is not enabled because it's not an option on this turbo.
So these turbos do calibrate, in case you're wondering, but it's actually done by the ECU. So because we're not trying to calibrate them to the frame like you would for a whole set turbo, every time we turn the key off on the L5P, the ECU actually calibrates it again. So literally every time you turn the truck off, it calibrates. So it's something you don't have to worry about on a bench. But if you're a salvage yard, turbo rebuilder, you can at least ensure that the actuator works. You can ensure that you're getting a full range of motion. So it's a pretty neat feature.
Yeah, these things are incredibly strong too. The Borg-Warner actuators are really built well. Whether it's a 6.4, the L5P, they're pretty reliable. Certainly as everybody knows, in the 6.4, make sure you update it to the waterless style. Completely different design. Really designed well. And that's pretty much it. So it's isolating the turbo, it's controlling the vanes. If the turbo is open, you see what was going on, but that essentially is what it is. In some cases you have information, some cases you don't, but it gets you, definitely gives you a good bill of health and lets you know what's going on. Now, if this was acting up, it would tell us, it would light up red and it would tell you that this thing is broke, essentially.
Yeah, you don't detect it. So if there's an error in here, it's not command, it'll say not detected because it's not broadcasting. Or maybe it doesn't move, so it jitters, like it jumps positions, only moves partially the way.
Yeah. Well, every time we do one of these videos, we start talking about the products, we always end up halfway, adding all these new pieces. So stay tuned, in future releases. Like I say, we're always adding turbos to these things, and turbos are coming out every day with brand new actuators. And again, I want to repeat, if any of you run across an actuator, we sell these things all over the world, so any of you run across any actuator that we don't currently support in the menu, send us the actuator in. It'll take us a week or so to backwards engineer it, to figure out how to operate it. We'll add it to the software, we'll get everything updated. So pretty straightforward.
So I was going to say, when we're moving these other turbos, we can kind of talk about where they came from. So we good with this one?
Yep, we're good with this one, so we'll move on to the next one.
Set this down.
So this is Garrett's biggest VGT turbo, at least that I'm aware of.
I believe it's 102 on the X-Deucer. This came off of an Iveco from South Korea. I believe it's about a 15-liter motor. So it should be the Iveco Stralis. Yeah. Hopefully
Now, if you pick the wrong one, it's not going to hurt anything. There's protection in the benchtop tester, so don't worry about.
So this is the first turbo that we connected. It's actually 24 volts. So this is off a heavy-duty truck with a heavy-duty power system. So as you can see, when Clint click oscillate, it didn't do anything. This turbo doesn't have a lot of feedback, so we can't really give you a lot of error codes from it, other than, hey, you selected this turbo. Go ahead and click it. So as you can see, it's counting, it's going. As it's counting up and down, it's not actually moving the turbo. And that's because you have to know a little bit about what it's coming from. So if you're getting these, your turbo rebuilder, and someone brings you a turbo, you really don't know anything about it, going from 12 volts to 24 volts isn't going to hurt the turbo. But as you can see right here in the supply voltage on the menu, we're currently at 12 volts. So I'm going to flip it to 24 volts. And now you can see that the supply voltage jumped to 24 volts and it's oscillating from yellow to white. And now you can also see that the command and feedback position is now commanding the turbo. I don't know if you can see that, but you can now see that the...
Kind of quiet, moving slow.
Yep.
So we'll go to the next turbo, which will be, so we're just kind of running through a few different actuators here. You know, there's a lot, you know, as you can kind of see here. You know, some of these we have on turbos, some of them, like these little Hella actuators, you know, we've got a...
So in the United States, the Hella, from what I've seen, is generally on the Sprinter vans. But they're on everything from Mercedes to BMWs, anything that's a small engine with a single or maybe parallel turbos that are VNTs. Generally, you'll find a Hella. So they're good for what they're meant for, small turbos. Try to put them on big ones. I think the biggest I might have seen is maybe into like the GT30 range. But they're generally for small turbos. So
Okay, we've got a BT501.
Yeah, so the BT501's already on here. So with the Hella right now, we have two ranges. Yeah. So we tried this on 24 volts. We forgot to go from the IVCO back to 12 volts. The cool thing is I've yet to have an actuator get shorted out because we had on one voltage together. So they're pretty versatile. So all we did is switch back to 12 volts, went to the correct range, and now it's moving back and forth.
It sounds like it's pretty good shape.
Yeah. So for the most part, all you're looking for on a Hella actuator, there is some out there have a lot more features, but the majority of them are really, really basic. They're just pulse modulation control. There's no real logic behind them. You tell it, give it a duty cycle, it goes to that position. That's all we're doing here. And really the only thing you can look for is make sure that it's going a full range. It's not jumping. So this actuator here is banged up, it's cracked. On that one, it's going to kind of go, stop, and then like jerk around. So it's not that healthy, but
Yeah.
nothing really more you can do. The biggest thing with the Hellas, there's actually probably about 5 or 6 different types of Hellas. They got pulse modulation, they got CAN, which this adapter does both. Then you have reverse polarity, and there's just tons and tons of variations. If it doesn't connect, don't force it. Don't take the lock out and then make it fit. If it doesn't fit that actuator, it's not designed for that
Yeah,
particular
if they
actuator.
really do, they'll change the pins around a lot. So just because it's close, you know, you can do some damage to the actuators if you try to force it.
Or to the tester. So go to range 2. So this one here you can kind of see.
Yeah, it's kind of jumping around, making funny
See,
noises.
right there, jumps.
Oh, nice.
So this actuator is not too good, and it makes a little bit more noise.
Yeah, that one you're going to definitely want to throw out.
Yeah, totally. And that's it for the Hellas. There's really not too much for them. As customers send us more, like I said, from my experience in the United States, we pretty much just use them on the Sprinters, but they're pretty prolific overseas. All right, if you don't mind, just go ahead and go to the Hino. So this is off a Hino, off of a Hino Ranger, little 4-cylinder. I think they're even up to 6 cylinders. It's a GT3571. I think the end part's KLVN. These are actually pretty common in the United States. So if you ever seen a Hino truck, most of them have it. So these can be calibrated. Calibration is pretty simple, but same thing as like the other turbos. For the most part, all you're doing is you're connecting to it, click oscillate, click calibrate, see if it works. So if you, sorry, I might have been blocking you on that, looking at the computer. Let's go ahead and just kill the power real quick. Get to reset, click calibrate one more time. So all it's doing is it's moving its range back and forth. So what's really cool about it is you can actually adjust the set screws and you can hit calibrate. And actually this actually might be a really good idea to demonstrate why the calibration is important on the whole set. We got a screwdriver we can grab real quick from the race shop.
Oh, in this shop?
Yeah.
See if we
Do
can
you
find.
have screwdrivers at ATS? So what we're going to do right now is I'm going to demonstrate why calibration processes are actually really, really important. Even though this is not a whole set turbo, it's doing the exact same thing. So I don't know if you can zoom in, but you can see right here, there's 2 set screws. Now I can manually adjust these set screws, run the calibration, and wherever that new set point is, it's actually going to recalibrate. So the easiest way is to use a flathead. We're going to stick a flathead in here. You're going to watch the sweep function. Probably bottom side's probably the better side. So right now it's counting up to 100. We're just going to set this in here and see how it stops. It's counting down to 0 and it's at 37. It doesn't know that it's locked up. So I'm going to stick it in here again. We're going to have Clint calibrate it, and you're going to see that the new range is going to take an account of the screwdriver. Now this goes back to what I was saying earlier. If you guys buy a aftermarket or some type of modified whole set actuator, and that actuator is not calibrated to your particular turbo, that actuator doesn't actually know what 1%, 2%, what the actual positions mean. So what's going to happen is when we calibrate it, it's going to take the span that it can move, which is 100 to 30. See if it works. It should now stop right there. And that's what the whole set actuator is doing. So when you rebuild the whole set actuator, or you pull that actuator off, you want to recalibrate it, because as you can see now, the new set point stops quite a bit off. So now it's rescaling, it's readjusting that span of what 0 to 100 means. From 0 being, let's say, closed, 100% being open, the range that it can actually go is readjusting it based on the limited position I created with the screwdriver. Now if we run it again,
recalibrate.
now you're going to see it's going to have that full range. Now this is why, like I said, you have to calibrate whole set actuators. Just because it bolts up, it says operating, it seems to be working, does not mean it's calibrated to that frame. You have to calibrate it to the frame of the turbo. And anytime you pull the actuator off, doesn't matter if you're just cleaning your truck out, draining the coolant, for whatever the reason is, if you pull it off, you want to recalibrate it. You definitely have to recalibrate it if you pull the unison ring out and you adjust all the gearing. So yeah, I should have thought of that earlier. Just like popped in my mind.
It's all right. Yeah, so it's a pretty good overview of the benchtop tester. You know, it's full of
6.4 too if you want.
Fantastic tools, and one more. Might as well do the 6.4 since we have it here.
Yeah.
BT 106.
This is this little test harness I have,
yep.
So it's not the actual one. We should have one though, I thought. Yep, right here. So take my test harness off. I don't even know why you have that. Should be in my shop. So this is actually the new 6.4 actuator. These are actually kind of nice.
Yep, no water. 6.4s that have water lines coming out of them, just get rid of them, junk them, they're terrible.
So you're on a 6.4.
Go to menu, you see the VGT calibration is grayed out. That means there's no calibration to it. Let's go to control and essentially watch it isolate. Make sure you get your 0 to 100.
Well, that's it. It's universal. If you guys have the benchtop tester is extremely universal. So disconnect that. So you're going to see that there's two Deutsch connections on the front. This one here is your CAN pulse modulation. This one here is your analog output. I should have brought one, but I gave it to Glenn. So this here will control stepper motors. We didn't have any here to demonstrate for you, but a stepper motor basically flips phases around, so it actually rotates the motor. So we can do that through analog.
It's really an expansion port for EGR control. We'll be offering the same control on EGR valves here in the future. So all of the emissions on stuff, all the EGR valves for all the medium duty trucks, the small trucks, big trucks, everything will continue to be updated. So you'll be able to add that to the list as time goes on, you know, for you rebuilders.
And this tool it's not meant to be like all these other products out there where you spend thousands of dollars and it only does that one function. This is designed to be a universal tester. Now granted, we're marketing it towards turbos, but that doesn't mean it's only for turbos. Like Clint said, it can do EGR valves. If you have, if your shop, doesn't matter if you're rebuilding injectors, if you're rebuilding solenoids, if you have an idea that you would like to see this thing do, just let us know and then we'll try to try to make it work. Because at the end of the day, it's to facilitate the need that you have, not the need we have. We have our need. We use this every day here at ATS. The goal is to allow you guys to facilitate the need you need to make your job easier. And you don't have to buy 60 tools. You can just buy one tool that potentially does a lot.
So that's it. So hopefully you guys enjoyed. Hopefully this will be a product you guys can really put your techs to use and help you make your customers happier and just provide a better service. So stay on our YouTube channel, ATS Diesel, and you can find this product at atsdiesel.com. So we look forward to the next show.